Hello everyone, I'm Mr. Furlong, and today we're going to color in the periodic table. Here on the screen you can see the periodic table of the elements. This lists all of the known elements that scientists have either discovered or have made. It's called the periodic table because it periodically changes. Sometimes we have to add new elements onto the table if scientists have made new ones. This is a little bit of an older one because it doesn't have all of the elements on there, but it's okay for our purposes. We're going to be doing some coloring as we identify the properties of the periodic table. As we go through this process, you're probably going to need to pause the video to give yourself a chance to do some coloring on the table. And let's start off with using a nice bold color, like maybe a red color. And we're going to draw a staircase on the periodic table. Now this is an important line because it separates all of the metals from the non-metals. So everything to the left of that staircase, those are all metals. And everything to the right of the staircase are the non-metals. And so you can see that most of the elements on the periodic table are a type of metal. There's very few non-metals. So this is where we're going to start coloring, and we're going to identify certain family names on the periodic table. The first family are known as the alkali metals, and we're going to color those in with a nice red color. So you can see that these are basically that first column in the periodic table, but not the hydrogen. Don't color that one in red. That's not an alkali metal. Again, you may need to pause the video in order to get those colored. The second family is known as the alkali earth metals. We're going to color those in orange, and that is the second row on the periodic table. The middle of the periodic table are the transition metals, and we're going to color all those in yellow. So most of the elements in the periodic table are the transition metals, even those two rows that are brought down below the periodic table. Now remember, everything to the right of that staircase is a type of metal, but some of the elements that border that staircase, sometimes they have some metallic properties, sometimes they have properties of the non-metals. Those are referred to as metalloids, and we're going to color those in green. So you can see that just about every metal that touches that staircase is a metalloid except for aluminum. That's definitely a metal. Now we go towards the far right and we have the halogens. So this is the second to the last column. We're going to color that in blue. And then finally we have the noble gases, and those we're going to color in with a purple. You can see that there's a handful of elements that are not colored in. Those are the rest of the non-metals. So we'll just color those in. So you can see that it is possible for an element to be considered more than one thing. For instance, fluorine is a non-metal. It's also a halogen. We know it's a non-metal because it's to the right of that staircase. Calcium, on the other hand, we know is a metal, and specifically it's an alkali earth metal. So there's lots of things that we can tell about an element based on its position on the periodic table. Let's continue making some markings on here. And we're going to identify the periods on a periodic table. Now a period is a horizontal row, and there are a total of 7 horizontal rows, or 7 periods on the periodic table. Why this is important is it tells us the number of electron shells. So that means that everything in period 1, which would just be hydrogen and helium, all have 1 electron shell. All the elements in period 2 have 2 electron shells. In period 3 they have 3 electron shells, and so on. Well, let's take a look at period 6. If you take a close look, and let's zoom in, it goes 55, 56, 57, 72. Oh, wait a minute here. What happened to 58 through 71? We see that there are 2 rows that have been brought down below the periodic table. And there we see 57, 58, and so on. So when we're reading a periodic table on line 6 and 7, we would go 55 through 57 and then down to that group below and then back up to where we left off. All of those have 6 electron shells, and we would do the same thing for 7 as well. Those have been brought down from the periodic table. There's a reason why. We're not going to worry about what that is. On the periodic table, though, elements are also arranged in families. Those are the vertical rows. Now, this tells us how many valence electrons there are. So let's identify these. And I'm going to be using an old-fashioned name for these. I like these better. They're families 1A, 2A, 3A, all the way up to 8A. All of the elements in family 1A have one valence electron. All of the elements in family 2A have two valence electrons. So you see how this is going? If it's family 3A, how many valence electrons do you think they would have? That's right, they would have three valence electrons. 4 would have 4, 5 would have 5, 6 has 6, 7 has 7, and family 8A has 8 valence electrons. Now remember, some of these also have names. For instance, family 1A was called the alkali metals. 2A was the alkali earth metals. But what about all those other ones? The ones in the middle? Well, those are known as the B families, and we can't tell how many valence electrons are present just by looking at their position on the periodic table. We'll be talking about these later, but all those other elements make up the B families. So later on, we're going to be working with the periodic table. Knowing this information is going to be very helpful as we continue looking at chemistry and how atoms interact with one another, and I'll see you in class.